Professor Ramanjan, Institute of Technology. Let's see the problem. If the marks of 300 students are normally distributed with mean 68 kilograms and standard deviation 3 kilograms, how many students have masses? First one, greater than 72. Second one, less than or equal to 64. Third one, between 65 and 71 kilograms inclusive. Let's see the solution. First, given data. Mean mass is 68, standard deviation 3, and total students are 300. So, for solving this problem, we have the formula. The formula is Z is equals to x minus mu by sigma. So, we have some steps to calculate. First step, calculate Z squares for each specified mass. Find the corresponding probabilities using the Z tables. Multiply by the total number of students with 300 to find how many students fall in each category. First one, students of mass greater than 70. First, we have to substitute x equals to 72 in the given formula. Z is equal to 72 minus 68 by 3, that is equals to 4 by 3. Approximately we will get 1.3. So, from the Z table, this Z is equals to 1.33 value is equals to the 0.908. So this is the value for mass less than 72. But actually we have to find the probability of mass greater than 72. So to find mass greater than 72, so we have to find first of all mass less than 72. So now probability of x greater than 72 is equals to 1 minus probability of x less than 72. So 1 minus, what is the probability of x less than 72? So 0.908. So we get 0.0918. So we have to find the percentage of that student. So we have to multiply and divide by 100. So then we get 9.18% of the students of mass is greater than 72. So now we have to multiply with 300. So 0.0918 into 300, we will get 27.54. So after round off, we will get 28. So approximately 28 students have a mass greater than 72. Now we have to find x less than or equal to 64. So before that, we have to take x is 64. So after calculating, we get approximately minus 1.33. So now we have to take the z values, z table values. In that, z of 1 minus 1.33 value is equals to 0.0918. Now with that value, we have to multiply with 300, and for this also we will get approximately 28 students. So 28 students have mass less than or equal to 64. Now we have to calculate between 65 and 71. So first we had to take x equals to 65. That time we will get z value is minus 1. And now we have to take x equals to 71, and that time we get z is equals to 1. Now take the z values for z is equals to 1. So the z value, when the z value is equals to 1, so the z value is approximately equals to 0.1587. When z value is minus 1, and it is approximately equal to the 0.8413. Now we have to calculate the probability. So the probability of the students having a mass between 65 and 71 is a difference between cumulative probabilities for these two z squares. So 65 is less than x less than or equals to 71. So 65 is z is equals to 1 minus probability of z is equals to minus 1. What is the probability of z is equals to 1? We get 0.8413, and z is equals to minus 1 is 0.1587. By subtracting the both, we will get 0.6826. So we want the percentage of the students. So approximately 68.26% of the students have mass between 65 and 71. Now we have to multiply that with 300. So we get 204.7, means approximately 204 students have the mass between 65 and 71. So after calculating this total, for students of marks greater than 72 is 28 students, and marks less than or equal to 64 or 28 students, and total marks between 65 and 71 or 205 students. So conclusion, in this exercise we use the concept of jet scores to standardize the data and determine probabilities by converting the given mass values into standard deviations. We could use the jet tables to calculate the probability of the student mass falling within each specified range. Finally, multiplying these probabilities by the total number of students gave us the number of students in each category.